Hey guys, welcome to Coronavirus Earth Science. Today we're going to be getting done days 17 and 18. They're pretty short mini lessons. Get it done, get it over with. This way we could finally be done with weather. Remember, I told you guys this was a huge, massive unit, but whatever. Don't forget, you got 3 assignments today. This week that are due on Friday, so please make sure you get them done. You got that worksheet on day 15, your CASA Learning, and your Google form. Just a heads up, in OneNote, I know that a bunch of you copied them over when this whole thing started. I put up newer, better worksheets. I retyped them because the original worksheets that I put in for 17 and 18 were all faded. So if you go in now into Content Library or in Schoology and you copy them over, these are way better worksheets, and you could see all the notes a lot better. All right, there's really no notes for you to take. Just follow along and pay attention. God, there's a plane going overhead, so that's good noise. The birds and the animals are going crazy. I didn't know which animals were better, the animals outside or my kids inside. All right, so here we go. Thunderstorms and tornadoes are how we're gonna start off talking. Let's bang out these do now questions. So here we got weather stations in the US. Letter X is an air mass that's moving in the direction shown by the arrow. A line marks a frontal boundary advancing southeasterly. All right, so which weather map symbol best represents air mass X at the frontal boundary shown at the map? So if you look at the temperatures, these are colder and these are warmer, right? And if this is the front and it's moving this way, if that's cold air, then it should be a cold front. So triangles for icicles, right? Next one. Okay, glad that's still there. Let me get rid of that. This one, which air mass is associated with a low relative humidity? So dry and high temperature. Dry and hot. Dry means continental over land, hot, tropical. An air mass classified as continental tropical usually forms over which type of Earth's surface? All right, continental means dry land, tropical, warm, right? So warm land. All right, so here we go. Thunderstorms, cumulonimbus clouds. Those are the big black ones, right? Rain, thunder, lightning, winds caused by fast, upward moving, warm, moist air, right? It's definitely going to be low pressure. If you look at this little animation, it's talking about electricity and lightning. Basically, it's a huge static discharge. Like when you rub your feet on the carpet and then touch something and you shock, it's just that on a bigger scale. Okay, so you got your electricity, which is electrons, which are negative charge, and they shoot down from the sky towards the positively charged Earth. All right, and that's essentially what electricity, lightning is. Thunderstorm safety. If you're caught in a thunderstorm, you're going to avoid high ground. You want to get lower, right? You don't want to be high up, because if you're high up, that means that you're closer to the lightning, and the lightning is going to want to touch you. You would be the first positively charged object. That's why people put lightning rods on the top of really tall buildings, so the lightning hits that instead of people. If you're in your car, stay in your car. You got rubber tires. Rubber tires are good because they're insulators. Lightning does not want to touch that or get inside, right? Self-explanatory, easy. Next, tornadoes, another low pressure system. Remember, we're talking storms today. We just did thunderstorms. We're doing tornadoes. We're going to do hurricanes after that. All storms, all low pressure, right? So tornadoes or cyclones, right? You got your fast, violent winds that are making that funnel cloud. These are going 300 miles per hour. That's pretty intense winds, right? Forms when you got your continental polar meeting your maritime tropical, and they start rolling on each other horizontally, and then they stand up and they form their cyclone funnel cloud. When we talk tornadoes, we're using the Fujita scale. All right, that is something that you should know. Remember how when we talked earthquakes, we said Richter scale or the Mercalli scale. When we talk tornadoes, we're talking Fujita scale. And again, it's going to be based on wind, and it's going to be based on damage. Okay, so you could take a look at this, read on it a little bit. Pretty intense. All right, tornado safety, get to the lowest level possible, because there's going to be a whole lot of wind going on above you, and that's going to be a whole lot of debris being blown around. So get inside, get to the basement, lowest level floor, stay away from windows. There's a common myth that I've heard before where they say open up the windows to allow the wind to go through. Nope, definitely not true. Close your windows, board up your windows if you have time. All right. So that is your tornado stuff. Tornadoes occur when very cold, dry air masses meet very warm, wet air. Which two air masses would most likely form your tornado? We said continental polar, maritime tropics, right? They're basically the two opposites. If a low pressure system follows a typical storm track, where is it going? We just said in the last lesson that everything moves northeast. And this next one, again, what direction is northeast? There's your number 3. Okay, so next we are going to move on to our quick lesson of hurricanes now. Okay, so again, now you're moving on to the next day. Here we go. So hurricanes are your ring-shaped storms. Winds are about 75 miles per hour or more, low pressure. So if I were to say what direction are the winds going, they're going inwards and counterclockwise, right? Maritime tropical. Remember, if we're talking hurricane season, these are going to be your warm seasons and your wet seasons. Lower the pressure, the worse the storm is, right? The faster the winds, the more water, the worse it is. The eye of the storm, that very inside area, it's very calm. So a reason why hurricanes really mess up some places is that you get the brunt of the storm first, right? If this is your hurricane, right, and it's going like this and it's coming this way, and you live right here, you're going to get this section first, and then you're going to get this nice calm in between. So people might come out of their houses for that and be like, oh, it's kind of nice. Oh, look, it's sunny out. And then boom, they get hit with this side of it next. So you always want to keep a radio, TV, if you can have power, batteries, so that you can keep track and listen to directions. All right, so how can we describe the path of the hurricane? We just said that it's maritime tropical, so it's going to follow the warm, wet path. All right, they're strongest over warm waters, so they're always going to follow the path of the warm waters. That's why most storms, if you look at the U.S., come this way through the Gulf of Mexico. Super warm waters, they sit there and they gather all that energy. They weaken over land and cold waters. The land and the cold water, that takes away all the energy. It slows it down, creates more friction, and then the storms end up dying. That's why New York does not get many hurricanes, because you got this system over here. It's called the Bermuda High. These are colder waters, and this is colder temperatures, and this is land. So most of those hurricanes are going to die right around there. Okay, when we talk about Hurricane Katrina a ways back, Hurricane Katrina started as a Category 1, then it came this way into the Gulf of Mexico and kind of just sat here for a couple days. And while it sat there, it just gathered all of that energy, and then it made landfall and totally annihilated New Orleans. Okay, so travel a curved path. Again, the curved path is because of Earth's rotation, that Coriolis effect, that southwest prevailing winds according to our chart, right? All right, so yeah, this is what I was just saying. Hurricane Sandy followed this path, so it was actually strong enough that it was able to make it past that Bermuda High. Oh, look, a helicopter. That's great. I'll talk louder. How are hurricanes measured? So We said earthquakes are the Richter and Mercalli. We said tornadoes are the Fujita scale. And now we are on hurricanes, which are going to be the Saffir-Simpson scale. And that's going to be based on wind, and it's going to be based on storm surge. And if you watch this animation, storm surges are basically the wind picks up those waves and they bring that whole water table higher and causes like that flooding that destroys so much. All right, forms when hurricane piles up water along the shore and winds blow the water inland. Extreme flooding and damage. This is what happened huge with Sandy, especially where I live. All right, how can we be safe during a hurricane? If you're going to have flooding, you're going to want to get to higher ground, right? Avoid that flooding. Close up your windows, board them up if you can. You got a lot of wind, hail, lightning, downed electrical wires, and flying debris. Safety procedures: higher elevation, avoid the floods, take shelter, board up your windows, make sure you have all your food, your water, your batteries, your flashlights, your radio, right? Remember what I said, you want to be able to hear when you know it's safe to come out, okay? Difference between a watch versus a warning. A watch is when hurricane conditions are possible, and then warning is when we know it's coming, okay? Okay, so one threat to human life. So why is a hurricane dangerous? You got that flooding, you got the storm surges, you got the wind, collapsing structures, right? Debris, lightning, all those dangerous things. And then number two, why does it get weaker? It loses all that energy when it hits the land or that cold water. All right, over here, state one way in which a hurricane differs from a tornado. Hurricanes are not going to be as windy, but they will certainly be wetter. Tornadoes are stronger and shorter. The path of a hurricane, remember, they're going to follow that warm water, which is in the Gulf of Mexico, and they're coming from the Caribbean. So you got choice one, right? Here's the Gulf of Mexico. And then over here, the center of this cloud pattern is most likely the center of, all right, all of these are storms, so we know that they are low pressure. All right, guys, yeah, this we don't have right now. So that's it on tornadoes, thunderstorms, and hurricanes. We are pretty much done with weather. So we got a little review, couple CASA learnings, and a summary Google form. Next week, I'm going to hit you with the project. All right, guys, be well. Get your stuff done.